Well, at the end of the last lecture, we were discussing the construct called distinct, right? So, in the last lecture, the last query we executed in the DBP endpoint was to retrieve the company names and their founders and the products, right? So, who have or have not founded a product that was coming inside the optional block, right? Now, so that is not of the point of interest in this query. So in this query, we want to see the distinct set of company names, right? So let us see the kind of query that we ran or executed in the last class. So the query was uh, the same query without the distinct part, right? And you see that we have got a repeated entry of say Microsoft and other companies, right? So what we can do with this distinct keyword is to find out a set out of a bag. Now you can see that this result is a bag of records or bag of tuples, right? And we can convert them into a set just by saying distinct. So we are trying to find out a distinct set of results, right? So if you do so, then you'll see that the list will be reduced and the list will be containing only one entry for each, right? Each record. So that's what you can do with the distinct keyword, right? So basically, using distinct keyword, you can convert a set. So you have a bag, is a bag of records. So you have a bag of records, and that you can convert to a set, right? So every entry has got one mention in the collection, right? Now we were using this filter construct in many queries without giving a proper treatment to it. So let us see what kind of constructs or what kind of structure we can have inside a filter, right? The filter can contain logical connective. So for example, I can say the language of a particular string is either English or Hindi, right? So for that we can use say or symbol, right? Or we can say that the uh, mm, language of something is not English, right? Or we can say the language of something is English and the say actor name is Hindi. So that we can implement with logical AND operator. So we can use logical connectives to combine different Boolean outputs to come up with a complex Boolean output, right? Now we can make use of comparison operators inside filter statement. Now we have made use of this already. This equal to we have made use of. Similarly, we can say that not equal to, less than, greater than, less than, equal to, greater than, equal to for different kinds of data like numeric data, date and time, and so forth. Right. You can use arithmetic operators. So while you are comparing something, so you can compute some value out of the existing values of the variables and then try to compare with something. So for example, if I say the addition of two values, say price 1 plus price 2 should be greater than say 50, right? So here you can see that we are using this arithmetic operator to compute something out of the values that are bound in different variables, like here in this case price 1 and price 2, and then we are comparing the result with some other value, right? We can use different functions, right? So we have already observed that we can use the lang function to see what are the kind of language tags that are annotated with a particular string, right? So the argument to the lang function is a string, so it should be a string always, right? Now, what bound A does, bound A really takes as argument one variable. So this argument to this bound function is a variable. And what does it return? It returns true. It returns true if the variable has at least one instantiation, at least one instantiation, and otherwise it will be returning false. Otherwise false, right? Now, what does this regex function do? So this regex basically represents regular expression. So this we have talked about earlier. So it is a regular expression. It is a regular expression. Now, this regular expression function has got two variations. In one variation, it takes two arguments. So first argument is a kind of string. So in most of the cases, these are variables. So you store some values in the variables. For example, we stored say the names of the actors in actor name variable, right? And this actor name variable will have some binding, right? And what it takes as argument in the first thing is it checks a binding, right? So actual input to this is one binding, right? So for example, you have a binding say actor equal to say Amitabh Bachchan, right? Now, so that is your binding, and that is your input to this regex function, which is basically a string. And then you specify a pattern. Now, this pattern can be constructed using the language of the regular expression in traditional sense, or you can mention a string also there as pattern, right? Now, additionally, you have another kind of regular expression function. So, apart from the string and the pattern, you can have a flag, right? And this flag will dictate whether you want to have this match between this pattern and the string to be case sensitive or case insensitive, right? So, uh, sensitive or case insensitive, right? So basically you want to ignore the case or not, right? So these are the kind of elements that you can make use of while you create a filter statement inside the where clause, right? Now, this is one particular example which is making use of multiple filter clauses inside a where clause, or but multiple filter statements, right? So here you are trying to retrieve the different names of the different authors, the books they have written, the title of those books, and the number of pages for individual book. But we want the author name to be in English, or the title of the book to be in English, and the author name to be in English. So here you can see that we are making use of this logical AND operator, and also we are trying to retrieve the titles for in which we have the word love, right? And this checking, this matching should be case insensitive. So here we are ignoring the case. So ignore case. So the details about different kind of regular expressions you can find in this embedded URL. So I'm not talking about that. Now you can also so we talked about bound function, right? So how we can use bound function? So this is an example of such a bound function. So what we are trying to do, we want to find out the movie actors who did not produce any movie. So you see that there are many actors who also produce movie, right? So we don't want the movie actors to be in our output who have also produced movies, right? So what is your knowledge graph will be looking like? So you have got say movie, and so this movie stars. So movie starring uh, actor, right? and you have something like, say, work. You have some piece of work, and this work has producer to be someone, right? Now you see, you have used the reversing of the path, but you can do the other way around. So that's not really a problem or concern in this particular example. But what we are interested in now, so this has been put in the optional part. So in some cases, the actor will be acting in the movie, but will not be producing something. But also, you will be having actors who acted in movies, also produce some movies, or produce some, yeah, produce some. So by using this work produced RDF type field, that means that they have produced, right? Now, we want to have in our output where this work produced variable is not bound. So this kind of example we have seen earlier. So as output, what we can get, say, actor name and say work produced, right? Now there will be some actors like A1, A2, they will not be having any value attached to work produced, but there would be some other actors who will be having, say, work 1 and work 2 to be the works they have produced also, right? So this movie, we are looking it as a kind of anonymous node, but see, you can do it in many ways. But so what we are trying to get as output is this set of entities, because for A3 and A4, the work variable, the work produced variable is bound. So here it is bound, and here it is also bound. Now, but here it is not bound, here it is not bound. So that's why A1 and A2 would be our output, right? Now, in many scenarios, you need to embed one complete query inside another query, right? So as you write, say, nested if then else statement, here you can also write nested queries, right? So in this query, what we are trying to do here, we are trying to find out the authors and the people or persons they have influenced, and the title of the works, the influence they have published, right, or produced or written, whatever it is. So in the this particular query has got two parts. So this is the inner query. So we have got one inner query, and here we are having one outer query, right? Now, in the inner query, let us see what we are doing. So, we are trying to find out the author name and the influence. We are just saying the author has got type to be writer and the author has influenced someone. So, this is our projecting variable, that because that is present in my select clause, and this author has got an author name. So, we are limiting this number of results to 1000. So, whatever value you'll be getting a tuple of two values. One is the author name, other is the influencee, right? And we are getting a size of 1000 records, right? And this set of records will be coming to the outer uh, part of the query. And here we will try to see what are the kind of notable works this influencee have done, and we are trying to extract the influencee name, the title of the work they have produced, and the titles they should be in English, right? So this is how we can write nested query, right? Now in many cases, whatever variables you have seen in the earlier queries, if you go back to the other queries, these variables, they are kind of replacement of either one subject or an object in the triple, right? But you have the triple structure at play. So here we are having this author to be in the subject position of a triple, and this author name variable to be appearing in the object position of a triple, right? So they are concerning the triple, but we can think of variables that are outside the subject and object places, right? So we can invent new variables so that we can store some values which we can compute out of the existing values and assign to the new variable which we are defining. So that kind of thing is called variable assignment. So we are assigning values to the variable by inventing the variable runtime while we are executing the query and storing some value in that variable. So here what we are trying to do, we are trying to find out the total area and the water body area of different countries, right? So how we can achieve this part? So basically, you are trying to find the elements or the entities that are of type country, and this country has got total area, and we have got something like percentage of area water, right? And we are storing that in water percent. So this is the variable that will have bindings referring to the percentage of area for different countries, water area for different countries, right? Now, as output, what we want? The country, the area, and here we are trying to compute the total water area. So here we are trying to compute the total water area out of the water percentage, right? So area of the water percentage, and we are assigning this total water area for that country in the water area variable. So this is the variable we have invented, and to store this total water area value, right? So with variable assignment, we are allowing a creation of new values while we are executing the query, right? So this value was not existing earlier. We are inventing this now. This water percent is a value we can directly get from the triples, but this water area is a variable which we are creating, the values for which we are creating. So let us run this query in dbpedia endpoint. So, okay, yes. So this is the query that we want to run. Uh, I see that these are the variables that were there inside the where clause, but this is what we have invented, water area, and this has been calculated based on the total area and the percentage of water area, right? Okay. Now the same thing we can do in different ways. So we did it in the select part in the earlier query, previous query, but we can do the same using some function called bind. So this is a yet another function, but this is not really returning a true or false value like bound. So this bound function should be treated differently than this bind function. So this bind function is a process which is binding some value to a variable. So this is another way of assigning values to the variable. So it will be doing the same task as we did in the last query by putting the assignment here using as keyword. So you were using this keyword. Uh, now we will be seeing examples of other kind of assignments. So here we are doing replacement of something and then assigning. So this is where we are computing a proper date. So what we are doing here, so this is the raw date value which have come from this part of the query. So basically what we are doing here, we are using one regular expression that says that you have 0 to 9 to be the values of date. You know, the date values, if we think about the years, they will be having entries to be 0 to 9, any value, and we want the date value to be of length 4, right? And but whatever date value we get here, we convert that into string, and then whenever we see any non-numeric character, so this is the regular expression for non-numeric character. So this is the regular expression for non-numeric character, right? And if we see any non-numeric character, then that will be replaced via blank. So for example, if you have something like this, June 2002, right? So in that case, JUNE will be removed, and whatever we will be getting is 1002. And we are placing, putting this value, assigning this value to year, right? So we are replacing some pattern. If we see some pattern in the date string, we are replacing that with blank. So that is the exact thing we are doing using this replace function. So there is another category of constructs which we call aggregation function. So we know that whatever things we have done earlier, we have just extracted values from the triples, and then we tried to manipulate that to come up with some new value. But there are some aggregation operations that we might want to perform. So for example, if I want to see that what are the kind of number of books that have been written by multiple authors, so for that I need to have a count function that will be counting the number of records for every author and book combination, right? If I want to sum up the total population of all the countries, so for that we need to have something like sum. Similarly, you can have average, minimum, max. Now, what does a sample function do? The sample function really picks up a subset of a list, a subset of the elements in the list non-deterministically. So, for example, you want to see, say, out of say 100 books written by the by one author, you want to sample some of the titles of the book, right? So it will just pick up some of the titles out of this 100 non-deterministic. Now, this sample sometimes comes with this group concat, where you create a group and concatenate the values, and then put that value in a single variable. So I'm not going to discuss these two because I don't find much use of this in this context, but if you might want to use it, so there are detailed specification present in several places. This is one of the places. Now let us focus on this core aggregation function, right? Now count is basically counting the number of records that you can have. So for example, I'm trying to find out the number of author entries in DBpedia. So there might be many authors around the world, but in DBpedia keeps record of a subset of them. Now how do we count the number of authors in DBpedia? Basically you are saying author is an instance of writer, and you are counting this number of records that we have, or basically the binding of the variable author, right? So this author can be bound with multiple values, right? And then you just count the number of bindings it has, and you assign that to the num variable, right? And our output would be a single value. uh, Now, I'm trying to find out the number of countries having larger area larger than that of India. So I'm making the query bit more complex. So what we're trying to do, again, we are trying to find something is of type country, and the total area of the country is the area, and we can find out the area of India to be area total by using this triple pattern. Like India has got area total to be area, and you are trying to put a filter that the area of country should be greater than the India area variable value, right? And we just have the countries, and to make sure that they are not repeated, you just put a distinct for the sake of safety. Then you just do a count operation on that, and then assign that value to the number of countries bigger than India, right? Similarly, we can do the same with the sum of the countries that have larger area than India, average, similar thing. You can do compute the minimum and maximum over van, right? So, for example, you have got area. Again, you have a number of bindings for this area variable, and out of this number of bindings, you are finding the binding which has got the max value, right? Now, if we just execute this query, it will give you the just a single value. So as your output, you will be having say max area with a value, right? Now, if I want to know which country has the maximum area along with the value of the area, right? So how do we do that really? So let me execute this query to put the thing in context. Okay, so we have this query, right? So let us mark it to be mean rather than max. So you see I should write mean area, otherwise it will be a number. So you have got the mean area to be 400, right? Now, as I changed my query a little bit or the specification a little bit, that along with this value, I want to know the name of the country which has got this minimum area. So for that, I guess you need to employ nested query. So you see that this is the outer part of the query where we are trying to find the area value that is minimum, so that you are storing that in mean area. So this particular part is giving you the area value, the minimum area value, right? And here you are trying to find, in the outer part of the query, you are trying to find the country which has mean value. I'm just saying this to be mean val, which has mean val as area, right? So you see that this is one good use of nested query. There are many usage of nested query, but this is one of the better example where you may want to use nested query. So let us run this. Okay, so you can see that it is giving you the name of the country as well as the area which has got the minimum area. Now, many cases this aggregation operations, they should be done over a partition data. So what kind of example scenario you are talking about? So for example, let's say uh, you have some actors, right? So you have got actors and they have worked in movies, and these movies they have got some runtime, right? Now one actor, say A1, has acted in some movie which has got runtime R1. A1 acted in say another movie which has got runtime A2, and A1 has acted in say uh, mth movie which has got runtime Rm, right? And similarly, you have got actor A2 who has acted in some movie which has got runtime to be say R1 prime and like this, right? So what do you want? You want for every author, so for every author you need to have one entry, and for that entry you want to have one aggregated value of this corresponding runtime value. So you want to get, say for example, average of the runtime, so average of the RI, right? You want to get, say, sum of the arrays, right? And you want to do it for the other authors, right? So basically what you are doing, you are partitioning your records based on a particular column, right? So you are partitioning your record based on, say, actor column, right? And how many partitions you will be having? Basically the number of actors you have, the entry in this record, that will be the number of partitions. And for each partition you are computing the aggregated value and putting that as your output value. So here we are trying to find the total amount of screen time. I'll not say screen time, yeah, screening time of the movies the actors have acted in, right? So I'm just trying to see what are the movies the actors have acted in, a particular actor has acted in, and I'm trying to find the runtime. And then we are grouping the record that we are getting out of this in by actor, right? And for each actor we are trying to get the sum of the runtime, and we are assigning the sum of the runtime in total runtime, right? And also along with grouping, we after we have got this aggregated data, so for example for A1 we have got, say, R1 AVG, right? And for A2 we have got, say, R2 AVG, right? So and then you get, say, for AN RN AVG, right? Now you want to present them in sorted order, so you have to present them. So this is your say average runtime, and this is your active, right? And to present them in the descending order of the, say, average runtime, you can do it for total runtime. So for that you need to use this keyword order by, and if you want to do it in ascending order you have to use DESC, and if you want to do it in ascending order you have to use AAC, right? So this particular order by keyword, it helps you to sort the record based on certain value, certain column. Now, in while we are trying to impose some constraint, in earlier queries we have used the filters, right? Now the filters, they are useful when you have some values computed against the existing values, right? So you can do the variable assignment and then you can compute different values, right? But these aggregation operations, you can see that they cannot be done inside this where clause. So you cannot perform aggregation operation inside the where clause, right? Because of the fact that this where clause is basically accumulating your result, and your aggregation should be applied over the accumulated results or the records, right? So that's why these aggregation functions, they appear outside the where clause. So you cannot really apply filter over the aggregated value, because we know that the filters, they appear inside the where clause. Now if we want to impose constraint over this aggregated value, we have to do that outside the where clause, and that we do with the having statement, right? So what we do in having statement, we are just saying that the aggregated value is greater than or less than something. So it acts like a filter, but it operates over the aggregated value. So that's what the difference. And the other difference is the filter appears inside the where clause, but having appears outside the where clause, and having does not appear inside the where clause. Now the queries that we have seen earlier, they mostly are select kind of queries. So you have some data stored, you compute the data, some other variables, and you project those variables using this select statement. And whatever variables you are projecting in the select statement, they will be appearing in your output stream, right? But we have got other kind of queries like yes no queries, where you get either one yes or no as answer. So for example, if I ask, was Paul McCartney a Beatles member? Right. So this is a very definite thing. You just have either yes or no as answer. So if you execute this query in say DBpedia, it will give you yes or no. But I don't want to use this in the SPARQL endpoint that we have seen in the browser, because these ask queries, they can be expensive, and you can get a timeout uh, uh, kind of thing while you run this query in the endpoints, because they have a timeout. But we can execute this query from the program. So while we will be demonstrating the programs or querying through the programs, we will be trying to answer this query. But for now, let us park this aside. Similarly, you can say that is there any movie by Chris Loden having duration greater than 5 hours? Now, I was talking about querying our database from a program, and for that, we can embed the query source using this keyword service. And in the service, after service, it should be followed by one SPARQL endpoint. And if you put this query in the program, of course, we should also come up with necessary libraries. Otherwise, you cannot write the program. Then you can get an answer to this query. Again, I'll be talking about this later. Now, the third category of the queries are construct queries, right? So where you construct triples. So if the difference between one select query and the construct query is that in select query, you really do not create triples, you create records, right? And records, they can be having any column name, but triple, there are only three column names. One is subject, the second is predicate, and the third one is object, right? So what we are trying to do here, we are trying to construct triples from existing triples, right? So what are the triples we can have? So for example, movies is starring one actor, right? Or movie has a producer, one actor. Now, if a person is acting in a movie or producing a movie, we say that person is involved in that movie, right? So we are creating a triple that if this is happening, if this is satisfied, then I can create a triple, construct a triple that this person is involved in a particular movie, right? So we can execute this query. Let us run this query and see whatever kind of thing I'm trying to say, whether that really happens or not. So we are trying to run this. So I'll just remove this part because this is not really necessary. Now let us give it some time to fetch our triples from DBpedia. It may take quite some. Okay, you can see that we have got as the column names as we talked about earlier, that we have subject, we have got predicate, and we have got object. So this we have not really explicitly mentioned to be the column names, in contrast to select queries where we have to explicitly mention the column names, right? And as records, what we have, the person, then this is the kind of new property that we have invented and used to relate say John Grayson with the law of enclosures, right? So this is a kind of film in which John Grayson has been involved in, either as an actor or as a producer, right? uh, Sorry, I need to put change the focus, right? So this is the thing I was talking about. So we have created the triples, and uh, John Grayson is the subject of a triple, and this triple we have created, and the predicate is a kind of new relation that we have established between John Grayson and the law of enclosures, which is appearing in the object position, right? So basically we are creating new triples. Now, also, this construct kind of a query, they can help us to represent rules. So how will that be possible? Let's say I want to encode a rule like this. So someone has got son. So if we know that someone has got a son, so Q1 has got son Q2. So let me draw it. So you have Q1 has son Q2. Now what you can infer from here, that Q2 has father Q1, right? So how we are constructing this? So whenever you see a triple like this, Q1 has son Q2, then you construct a triple like Q2 has father Q1, right? So this is a very simple rule. Let us look at a complex rule. So how do you define that Q1 has uncle Q2? First of all, Q2 should have a sibling, right? So Q2 has sibling, say P, right? And Q2 should be a man, right? So I'll say type of Q2 is man, right? And Q1 has parent P. Q1 uh, Q1 has parent P. If this is happening, then you infer that Q1 has uncle. So this is what you are inferring. So I should be writing a dotted line. So Q1 has uncle Q2, right? So these are the triples if they become true, like Q2 has sibling P, Q2 has type to be man, instance of man, and Q1 has parent to be P, then you can infer this kind of triple that Q1 has uncle Q2, right? So you see that we can also represent different rules using construct query. So with this, let us stop discussing about the SPARQL queries. So more or less, I have tried to cover different constructs that you can have. So this SPARQL used to have a simpler version, and then this has been elevated to SPARQL 1.1, which has got different features like this aggregation operators and other. So I'll not say this is a very comprehensive coverage of SPARQL language, uh, but I will request you to go through the documentation and write the queries on your own to get a good grasp on SPARQL. Thank you very much.